One of the toughest topics for students to grasp in Algebra 1 is polynomials. I mean, think about it. Students are expected to multiply, factor, complete the square. All of these things can feel very abstract for an Algebra 1 student. But Algebra tiles can make all of those topics make sense. It's something concrete, it's engaging, and it's a way for students to really think about what they're doing. Hi, I'm Rachel, and I'm going to help you learn how to use Algebra tiles so that you can use them when you teach polynomials. Instead of overwhelming students with lots of steps that often don't make any sense, we're going to give them something hands-on that's going to feel more like a puzzle as they figure it out and connect everything so that it makes sense and so that they remember it. Now, I've always loved math, and I learned polynomials without using algebra tiles. So why am I telling you that? Because when I started playing with algebra tiles, I had so many aha moments. I wish every student got the opportunity to see how the algebra tiles help all of those steps come together. They deepen the understanding for students of all levels. So go ahead and grab some algebra tiles and join me. We're going to go over the basics, and then we're going to talk about how we can use them to multiply polynomials.
First, we're going to talk about what algebra tiles represent. It's important to go over that with students, especially if they have never used algebra tiles before. So this little tile here is the unit tile, and typically the yellow side represents 1 unit, a unit of 1. And then if it has a red side, the red would be -1. Your tiles may have 2 sides like this, or they may be completely separate tiles for positives and negatives, but that represents 1. So getting students just to play with that and be comfortable with that is good before moving on. So we might ask them, show me a value of 3 units. So go ahead and play with your tiles and show me 3 units. Now here are some possible answers that you may have come up with. Maybe you're just showing 3 unit tiles, or maybe you're showing 4 positives and 1 negative. Or, maybe you want to show 5 positives and 2 negatives. So you get the idea here. We can get creative. All of these represent a value of +3, and that's important for students to understand. Now let's show a value of 0. Still just using the unit tiles. See what you come up with. Now here are some possible answers. 1 positive, 1 negative. Maybe you did something like this. 2 positives, 2 negatives. You can get creative depending on how many tiles you have, of course, but you see the idea. As long as they have an equal value of positives and negatives, that total value is 0. Or this here is showing nothing at all. That also is a value of 0. Okay, so let's move on to using the X tile. So that is the long rectangle tile. It's usually green, and that has a value of just X. The green side is positive, and if we compare it with our unit tile, that will reveal some things. So the X tile has the same dimension as the unit tile, 1, but we don't know this length here. And that's what we call it X. It's unknown. So that's why this tile here has a value of X. There's something unknown about it. Even though we know one dimension is 1, we don't know this other dimension. So this is our X tile. The value, when you see this, is just X. So we could ask students again to kind of play with their tiles and show us some different values. Be sure they know the back, or the red tile is going to represent a -X. Now let's see, can you come up with a value of -3x using your algebra tiles? So here are some possible answers. We might see 3 red X tiles, or maybe you have 3 of the negative X's and 1 positive. Again, you can get creative, but we want students to realize that all of these have a value of -3x. All right, now let's move on to this big tile here. And again, it might be good to ask students, what do you think the value of this is? If they've never seen it before, ask them, what do you think this value is? And use your other tiles to kind of justify your thinking here. So again, if we line this up, and you can see on the screen here, we can test out the dimensions. And this big square tile, its dimensions are X both ways, which means that its total area here, its value is x squared. So this is our x squared tile. If we flip it over, we have our negative x squared tile. What is the value shown below? This is a good way to practice with students, just getting familiar again with using algebra tiles and knowing what the values represent. So here are some examples we'll go through kind of quick. Again, feel free to pause if you want to try it out if these are new to you. Here we have 2x, whoops, let me go back, 2x plus 6, because we want to be sure we're paying attention to what's positive and what's negative. And then we can try this one out. Here we have a negative x minus 3. If we look at what's positive and what's negative, we can see how those values, how like terms can combine, but we cannot combine the x's and the units. And then here, using all three types of tiles, we have a value of x squared plus 2x plus 3. Okay, so let's get into multiplying. Now that we know what these tiles represent, let's see if we can multiply with them. Let's do some operations. All right, so we're going to build an area model, just starting out with something very familiar, just multiplying whole numbers. So since we know these numbers, we're only using our unit tiles right now. Let's just kind of reiterate what area has to do with multiplication. In case students aren't familiar with that, it's good to go over that when we find an area, we're multiplying two dimensions. Those dimensions are our factors, and then the area we find, that's our product. So if we place 3 tiles in one dimension and 2 tiles in the other, we can fill in that area to show the product. And we can see how a product of 6 works here. All right, now let's try one with an x. Let's try to multiply x times 3. So again, we want to fill in our dimensions. If you're doing this with physical algebra tiles, you're arranging them on your paper, on your desk. If you're doing it with digital ones, you can kind of line them up on the screen how you want them to look. But then we want to fill in this area. So if this is the first time doing a multiplication problem with algebra tiles, you might be thinking, okay, what do I do here to fill in this area? So to fill in the area to match those dimensions, we're going to end up needing 3 x tiles. So x times 3 is equal to 3x. Now let's build an area model to show negative 3x times 2. So feel free to pause or go ahead and arrange your dimensions in both ways. Okay, if you got that, now fill in your area. Now, did you think to use negative x tiles? Now here we have negative x's because a positive times a negative is going to equal a negative. We need students to know that going in. Hopefully that's something they remember from middle school. Because that will affect their final answers when they're filling in the tiles, either positive or negative. So here we have a final product of negative 6x. Okay, let's try this one out. Negative 2x times negative 4. If you got your dimensions, now fill in your area. And so this one we can see in negative times a negative is going to give us positive for the product. And here we have a positive 8x. Okay, now let's try building these dimensions. X plus 3 times 2. Now that we have it lined up, we can fill in with the tiles. All right, and so what's our final product here? 2x plus 6. Now you could get into distributing with students. I think that's fine. That's probably something they already knew the answer to without the algebra tiles, and that's fine. But here, using these basic problems, we're getting students to just see how this area model works using the tiles. So as we start getting into these more complicated problems, they'll have that foundation for how do I work with these, okay? All right, again, let's try 3x times x. So we're getting a little trickier here. 3x times x. Once you have your dimensions, how do we fill in this area? Well, now we need our x squared tiles because they have that dimension of x and x. So that product here is 3x squared. Okay, let's up the difficulty just a little bit. So go ahead and try to lay this one out with your algebra tiles. negative 3x plus 5 times negative 2x. All right, check and see, is this how you have your dimensions? Is this how you have your two factors? And then fill in that area. I'll give you a minute. Okay, were you paying attention to negatives and positives? And go ahead and check and see what you got here. With our negative x times a negative x, we got to be sure to fill that in with a positive. And then over here for our positive 5, when it's multiplying times those negative x's, those are going to be negative x's filling in that space. And so now students can just look at this and see what is represented here in the area. What is that value? I see these 6 big blue tiles, so that's our x squared tiles. And then I see these 10 negative x tiles, and that's how I come up with my final product. 6x squared minus 10x. All right, now here I like to get students thinking a minute because I want to try to prevent a mistake that often happens. If we look at the expression 1 plus 3 times 2 plus 4, those are our two factors. Look at how one student tried to simplify this expression. And this is a good discussion to have with students because they can quickly figure out if this is right or wrong, okay? We could go ahead and simplify up here. We know that 1 plus 3 is 4, 2 plus 4 is 6. We can do 4 times 6, and we know that something went wrong here with this student work. But figuring out why and what's going on is important for students to realize because they often do this mistake when variables get involved. Getting students to look at this and say, well, you can't just multiply the 1 and the 2 and the 3 and the 4. That's not how that works. That's the mistake. Getting students to really think about that and why it's getting a wrong answer is going to help them as we move forward with variables. Okay, so let's show an area model with tiles. 1 plus 3 is a factor and 2 plus 4. You can build this out or you can watch here how it might look. So on the top here we have our 1 and 3. And then along the side, 2 and 4. So yes, our two factors are 4 and 6, but we're just splitting them up just to see what's going on here. And then we fill in the area to show it. So now we can see that total area of unit tiles is 24. And we can kind of backtrack to what that student did before and see which pieces they were missing in this area model. Okay, now let's try it with variables. Build an area model to show x plus 3 and x plus 4 multiplying together. All right, check your factors here. And now you can fill in your area. Feel free to pause. I'm going to go ahead and show it. All right, so now we can see all the parts of this multiplying. You know, we probably know, okay, we're going to multiply 4 things, but students just learning this who haven't done this before, they haven't thought through that, but we can kind of see where those 4 pieces are going to come from. So we have our x squared. Now if we count up all of our x tiles, we have 7 of those and 12 unit tiles. I'll let you try it again. I'm going to move a little quicker, so be ready to pause it if you're working along with me. We have x plus 3 and x minus 2. Here's how that will look when you set up your two factors. And then you can go ahead and fill in the area. So we can see here, when the x's multiply, we get that positive x squared. But now we see, let me back up. Now we see we have some positive x's and we have some negative x's, and we're gonna have to combine those. So that goes back to that practice we did with just thinking about the value. If you have 3 positives and 2 negatives, that's only 1 positive. So we have a positive x and then we have minus 6, negative 6 units. All right, try this one out. 2x minus 3 times x minus 1. Here are our factors, and then we can fill in the area. All right, so again, we're paying attention to signs here. We're getting some negative x's, but then we end up with positive unit tiles when we multiply those. All right, now let's catch one more mistake while we're working on multiplying. Consider the expression x plus 3 squared. If you've taught multiplying binomials, you probably know where I'm going with this. What is the common mistake that students make? And let's look at how one student might try to simplify this expression. Ooh, have you seen that before? And they think their final answer is x squared plus 9 because they just get in this motion of, okay, I'm just gonna, I'm just going through this procedure, I'm not really thinking. But if we stop and think about, is this correct? I hope working with the algebra tiles, students have gotten in their head this kind of idea of setting up factors. And they probably or hopefully will realize, I think I didn't multiply something. I think something's missing here. And if we set it up with algebra tiles, then we can see what was missing from that answer. So if we set up our factors, x plus 3, both dimensions, and then we fill them in, ooh, then we can see the missing pieces there. We're missing 6 x tiles that we just completely forgot about. So our total area here is x squared plus 6x plus 9. This is one of my favorite reasons to use algebra tiles when multiplying. I do think it helps students to not make these kind of errors. Let me answer a common question I get about using algebra tiles to teach polynomials. Teachers often wonder, if I spend this time with algebra tiles, won't students rely on them? How will I ever move along to more efficient methods, or how will I ever get to the standard algorithm? And that is a good question. I don't think students will rely on these forever. I do think it is maybe an extra step in the beginning, but it's one that allows them to kind of pause and think about what they're doing. It's one that will let that learning kind of sink in, and they'll make some meaning of what they're coming up with for solutions. But I do think it's important that they eventually move along to using the standard algorithm or using more efficient methods. So I want to show you how this connects to the box method or the more written method, and then the standard algorithm. So let's take an example like this. X plus 3 times x plus 2. If we look at our algebra tile model, we can see how it's set up. And then we can transition to the box method. I call this the box method. You could call it area model as well. Just the, I guess it's the written area model. It's not using the tiles. And I think it is a quick transition. Once students are familiar with algebra tiles, I think they can move on to using this box setup first, and it'll make sense. So using this, if you haven't seen it before, they're filling in an area in each box. It's an area model. Many students use this now in elementary school for multiplying multi-digit numbers, so it is something they may be familiar with. But if we fill in each of these products, it relates to what we're seeing going on in the algebra tile model. X times x gives us a value of x squared. X times 2, that gives us a value of 2x. You can see how this relates to the tiles. X times 3, there's our 3x. And then finally 2 times 3 is 6. So we can see how each spot relates back to the algebra tiles. And then to get the final product, they're adding these pieces together, which is what we do with algebra tiles. We're just adding up all the terms, keeping in mind that some are unlike terms, and we're writing our final product. Here we have x squared plus 5x plus 6. So if you haven't tried the box method much, here's an example you can try it out. Try this just drawing your boxes and writing your factors, and see if you can get that total product. So there we have a final area or final product again of 2x squared plus 22x plus 56. Let's do one more. This one involves squaring. Again, I'd rather students pause and think a minute instead of trying to just square the two numbers. If they write their box, they're more likely to not forget about those two terms that go missing sometimes. And then they can add the like terms and get their final answer. So like I was saying before, I love to show this. This is how that area model gets used throughout the grade levels. I hope that your students have been exposed to it before. It is really useful for all of these different ways that we multiply. Area is multiplication. So using an area model to multiply different types of numbers just adds a lot of meaning. So to transition to the standard algorithm, you can see here we have algebra tiles, we have an area model. Now let's watch the standard algorithm and how does it relate? So again, we're multiplying each term in the first binomial by each term in the second binomial. And the way I'm showing it here, I know a lot of people either FOIL or draw the rainbows, and I don't think that's bad, but what I have seen is if you split it up like this, it will help later when we get to factoring, when we get to undoing all this. If they see this setup, it really does help them see later a way to factor. So I think it's important to spend time with students letting them compare. I don't think students will get stuck and say, I want to use algebra tiles forever. The algebra tiles are meant to add meaning when they're learning how it works, and then they can transition to the more efficient methods. The danger in starting with the standard algorithm is that they don't make sense of it. They're just learning steps and they're not really sure what even is going on. Algebra is so abstract anyway. I think when we give them something tangible to start with, all of the things we build on will make more sense and they'll remember it better. They're less likely to make careless errors or forget what they're doing later down the line.
Let me know in the comments if you're going to give this a try with your students. And join me in my next video where we'll factor with algebra tiles.